In high school science, we can only analyze linear graphs, straight line graphs. But sometimes the graphs that we get are not straight. We have to linearize it, we have to straighten it. So if a graph looks like it's square, then we need to graph the square of our manipulated variable on the x-axis. Similarly, if a graph looks like it's cubed, we need to graph the cube. And if the graph looks like it's root shape, then we need to graph the root of our manipulated variable on the x-axis. And lastly, if the graph looks like an inverse graph, then we need to graph the reciprocal of our manipulated variable on the x-axis. Let's look at a couple of examples. So let's straighten this first curve here, right? You have a set of data tables here, and you graph it initially, and it looks like a square graph. So what we need to do then is to square the manipulated variable, the x values, and then graph that on the x-axis. So once we square the x values, it now becomes 1, 4, 9, 16, and 25. And then when we graph the x squared here on the x-axis, we see we have a linear line, we have a straight graph. Then we can use the value of the slope of the straight graph to solve for our various physics unknowns. Let's try it with another graph. Here we have a table of values again, and when we first initially graph this table of values, we see we have an inverse function. And according to our chart on top here, if the graph looks like an inverse, then we should graph the reciprocal values of our manipulated variables on the x-axis. So we need to generate a new data table with the reciprocal values of x. So the reciprocal of 1 is 1. The reciprocal of 2 is half. The reciprocal of 3 is 1/3 or 0.33, and so on. And now we can graph this, our new data table. Once we do that, we graph the inverse value here, 1 over x. And once we graph y versus 1 over x, we see that we have a linear graph now. We have a straight line. And once again, we can use our straight line to graph to solve for any physics unknowns.